Hi, this is Hannah.
This is Jody.
This is Nicole.
This is Zumi, and this is our project on dining hall meal trackers.
Nicole and Hannah worked on the scale and Arduino to monitor the weight of each individual's tray.
And Jody and Zumi worked on the beacons, webcam, and Raspberry Pi to monitor the location of the individual and picture of the tray.
So first we're going to give a brief introduction to our project. Basically what our project is, it's a part of the Net Health project that's being conducted by Professor Strugel at Notre Dame to track and log what students might eat in the dining hall. The point of the project is to try and overcome the psychological barrier of manually having to log food and instead record their natural choices by having them not log the food themselves. And so, some related works to this project include the study, does selection of foods in the school cafeteria by 6 to 8 year olds translate into consumption? Results of a cafeteria observation study that included iPad digital photography, manual logging, and image data. And one other related work includes the Orange Chef Prep Pad, which used Bluetooth with countertop, UP Jawbone, manual logging, and recovered weight data. Our project uses Bluetooth technology, image and weight data, and includes an automatic logging system.
Each student in our project will be given an iPhone with an app that can communicate with the iBeacons that are located in the dining hall. There are a few iBeacons spread out in the dining hall to track the location of the student. As the student walk around, the iBeacon will communicate with the iPhone and send the distant location of the student to a HTTP port. And as the student is in the proximity with the Raspberry Pi, it will trigger the Raspberry Pi to take a picture of the student tray as well as recording the weight of the tray and send that data to the server. And at the end, all the data will be sent to a grad student to process.
Hi, Nicole. Say your name.
My name is Nicole.
All right, Nicole's going to show us a demonstration of how our project's going to go. So she has the iPod in her hand. Cool, and she's going to walk around the room with the beacons.
And this dining hall tray. Okay, so I'm rolling around the dining hall. I'm like, oh, I think I want to know whatever this is.
Point to the estimate. Awesome. So it's going right here to the screen with the socket on there, and Nicole's going to go to the other estimate. Cool. Awesome. So it's also going to the server as well. Now she's going to go to the weighing tray table. Okay, so Nicole needs to make sure that the app is next to the estimate close enough so that it takes the picture. Perfect. It's now there. And then Zumi is now having the Chrome tab take the picture. It has the weight there for us. If you can see it. Right there. It's the picture on the screen of the Raspberry Pi, and that's how this works.
There were several challenges we had to overcome during our project. One of them was choosing the correct beacon for this project and which would be best. We started with gimbal, and then from unanimous decision we decided to go to estimates. Another issue was the scale and being able to communicate the scale with a Raspberry Pi or being able to log it dynamically. The last problem was using Xcode. For neither Zumi or I ever used Xcode before, so that was kind of a dive into the pool kind of thing there.
So to wrap up our presentation here, we managed to get all of the information out of this project that we were looking for. We got the weight from the scale, we got the pictures, and we got the location information from the beacons. Additionally, all this information gets sent to our Dropbox database at the end, so it makes it easily accessible from anywhere, which is pretty cool.